Okay, 2006. B. I meant to, hold on. I meant to put a, you're going to let me do this, B in here. I realized that after I was done. Um, okay, so we have to draw the Lewis electron dot structure for all four of these. So we're going to need a lot of space. So first question is GeCl4. I put the Ge in the middle, and then I do Cl4, and then I go, the middle guy has 8, no dots. This one needs 6 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 dots. And if I do ORP, 6 and 6 and 6 and 6 is 24, 26, 28, 30, 32. ORP is 32. VE is going to be 4 because GE is in the same family with carbon. Plus 7, plus 7, plus 7, plus 7. 4 times 7 is 28. 28 and 4 is 32. And remember, when these match, that's the picture. And so I'm just going to go down here and I'm going to say this is an AB4, which means it's tetrahedral, yada, yada, yada. Okay, I'm going to add a slide right now. Next guy, switch colors, go to red. The next guy is SeCl4. And you're going to notice that all of these ORP is the same. So you put Se in the middle and you go Cl, 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 Cl. This needs 6 dots. This needs 6 dots. This needs 6 dots. This needs 6 dots. This needs no dots. ORP again is 32. However, VE is selenium is in the same column with oxygen. So 6 plus 7 plus 7 plus 7 plus 7. 4 times 7 is 28. 28 and 6 is 34. And so this means we have an octet rule expansion. And so I need to put a pair of dots on the central atom. And this ends up being an AB4E1, my favorite shape, seesaw. Or distorted tetrahedron, whichever you prefer. Next slide, going to green. Now we got ICl4 minus. And so when I do this, I get the same, put the CLs around. This guy needs, they all need 6, none on the iodine because 2, 4, 6, 8. Again, ORP is 32. You're going to see that in all of these. VE in this case, though, is 7 plus 7 plus 7 plus 7 plus 7 plus 1 because of this negative charge. And 35 plus 1 is 36. And so now we have a difference of 4. And so we have to add 4 dots on the central atom. This is actually an ion, so I'm going to put minus 1. And then this is an AB4E2. AB4E2, which you remember is called square planar. They're not asking to say it. I just got to get the pictures drawn because that was the first thing. And now this is kind of interesting. So the switch colors. The thing is, it's exactly like the one before it with this exception. So we get ICl4. Same thing. By the way, this is ICl4 with a plus charge. We don't get a whole lot of these, but we probably should. And then when I do ORP again, you get 32 because ORP assumes you have all single bonds and everything has exactly 8, except if it has Habib in it. And then when you do VE, it's 7 plus 7 plus 7 plus 7 plus 7 minus 1 because this means you got rid of an electron. You lost 1 electron, which gives it a plus 1 charge. And so then this is 34 again, and this is a lot like the second picture we drew, that there's 1 unshared pair. And then this is a plus 1 charge. And again, this is an AB4E1, which is seesaw. Now, after you get these pictures drawn, this is a very easy problem. They ask you questions about them. On the basis of the Lewis structures drawn in Part A, answer the following questions. What is the the bond angle between germanium, chlorine, and chlorine, and this is 109.5 because when you have a tetrahedral molecule, that's the bond angle. It's no less than, it's exactly. Is SeCl4 polar? Yes, SeCl4 is polar. Here's why. What two things do you need to have a polar molecule? You need to have polar covalent bonds arranged asymmetrically. So let's go back. We have 1, 2, 3, 4 polar covalent bonds. And this unshared pair destroys the symmetry because remember the parent structure is trigonal bipyramidal. And then and then when you erase this one right here, there is your seesaw. Here's your fulcrum. If you turn it on its side, there's the fulcrum. And then there's the seesaw. If you turn this on the side, that's where that seesaw name comes from. But you have 4 polar covalent bonds asymmetrically arranged. So yes, coming over here, yes, SeCl4 is polar. And then it says, explain. The molecule contains 4 polar covalent bonds. Remember, that means you have an electron shift towards the more electronegative element, which are asymmetrically arranged. So the molecule would have a dipole moment. All right, cool. What's the hybridization of ICl4? Oops, I can't read this. Yeah, ICl4, and I don't know why, but in here I can't see the minus, but I can see it on your worksheet. And so if you go to ICl4, it is an AB4E2. And so 4 plus 2 is 6, so it needs to involve 4 bonding orbitals and 2 non-bonding orbitals. So 4 plus 2 is 6, so it has to be sp3d2. And what is the geometric shape formed by this seesaw? I already wrote that. That was actually a pretty fast one. And that is it.